I want to review doing Euclid's algorithm, but also the extended Euclid's algorithm. So let's say we're given a problem where we want to show the GCD of two numbers, 7, 1, 4, and 1, 1, 4. So two relatively large numbers that we can't do in our head. We can start out solving this by using Euclid's algorithm. So that means moving 7, 1, 4 and setting it equal to 1, 1, 4. And how many times 114 goes into 714? 6 times, with a remainder of 30. Okay, so you can pull out your calculators or do the math on the side for that. But the next step is to shift the 114 to the left-hand side of the equation and shift 30 and see how many times 30 goes into 114. In this case, 3 times. 30 times 3. That's 90 with a remainder of 24, solves for 114. Okay, then we repeat this process again, move over 30, move over, do the shift for 24, that goes in 1 time into 30 with a remainder of 6, and now we can shift over 24, we see that 6 goes in 4 times to 24 with a remainder of 0. Okay, so as soon as I get this, Euclid's is over, and when we get 0, we notice that the 6 here, this is our greatest common denominator, 7, 1, 4, and 1, 1, 4. So you can do the prime factorization for these numbers if you want to verify, but for now we can just trust that that's the right answer. So if I want to use Euclid's extended algorithm, I would do this such that I can, I want to solve for the equation such that I get the number 6, which is our greatest common divisor, and set it equal to 714 times some value here, plus 114 and some other value. So this is known as a linear combination if you search it, but this is also looking similar to Bézout's theorem, which we had D equal to AX plus BY. Okay? Where D was our greatest common divisor. Alright, so if we want to write things in this form, how do we start? Okay, how we're going to start is where we left off down here with this 6, and rewrite in terms of this equation here. So 6 is equal to 30 on this side, and then I need to subtract 24 times 1 here from the other side, so I can do that by simply adding 24 times negative 1. Okay, so we can verify at any time here. 6 is equal to 30 plus negative 24. Okay, so that holds true. And now where to go from here, this next step? So we use the sort of GCD here from this equation, but now we want to use our remainder here, this 24, and see where we can substitute it in this equation here. Okay, so let's try that. So if I said 6 equal to 30 plus, we have a minus 1 out here, I'm just going to pull it out front, and 24, if I'm focusing on this equation here, is equal to 114, and we're going to use that same trick of plus 30 times negative 3. Okay, so I know that went a little bit fast, but I'm essentially moving this 30 times 3 over to the other side of the equation here, right? So we just need to subtract. Okay, so once I've done this step, let me distribute out this negative 1 to make things a little bit nicer. I get a 30 plus 114 to the minus 1 plus this will be 30 times 3. Okay, we simply flip the sign here. Okay, so at this point in the equation, I want to be careful not to add these numbers. At any time I can verify that this works, but let's combine some terms. So this 30 can move into this group of 30 times 3 to give us 30 times 4. So this is the same as 114 times minus 1 plus 30 to the 4th. Okay, and I can verify that Negative 114 here plus 120 is still 6. Okay, so far so good, and this is a nice form of the equation where we see that this 30 here can be substituted again from this form of the equation. So let's do that. So 6 is going to be equal to, I'm going to draw my 114 minus 1 plus, I like to move the 4 out front here, and then working with this side of the equation, 714 plus the part that we're moving over, this 114 times 6, 114 times negative 6. Okay, because remember again, we moved over this 114 to the other side of the equation when we were setting it equal to 30. Okay, so now let's repeat and distribute. 6 equals 114 times minus 1 plus 714 times 4 plus 114 times this negative 6 and 4. It's going to be negative 24. Okay, so far so good. Let's combine our terms because we've noticed that we have a 714 here and 114, which is what we originally started out with. This is our A and our B here. Okay, so 6 equals 114 times, how many do we have? Well, we have minus 1 here and minus 24 here. That's minus 25 plus 714. We have 4 of them. So if I actually take a moment with my calculator to check what those are, I get the following numbers, where 114 times negative 25, this value is equal to 2,850, negative 2,850, plus 714 times 4, which is 2,856. And I can look at these and say, okay, this is actually 6 here, which matches the left-hand side of the equation, which is good. And now we can fill in our blanks here. 4 and minus 25 are the coefficients. So the nice thing is you can always verify during this process if you've made any math mistakes by simply doing the math. Okay, so this is extended Euclid's algorithm. And we've used a method known as the backward substitution to solve this linear combination.